right, guys, we're on the back side of day 7 notes, and in number 3, it says, prove that the diagonals of the quadrilateral whose vertices are A, B, C, and D do not bisect each other. Bisect means to cut in half, and the halfway point is called the midpoint. So we're going to use our midpoint formula, and we're going to do it 2 times, okay? In this one, we have to watch out because it's the diagonals that we have to do the midpoint of. So graphing it might help us determine what the diagonals are if we don't already know. So A is at +3, +5. B is at 6, 4. C is at 7, 8. And D is a little off the graph, but that's okay. It'll still give us an idea of who our diagonals are. Okay, so one of our diagonals is DB, and our other diagonal is AC. Okay, and we're trying to prove that this is not the midpoint of both of them. Okay, meaning that they don't cut each other in half. So here we go. We're going to do the midpoint of one of our diagonals, which is AC, and then we're going to do the midpoint of our other diagonal, which is BD. We'll set up our formula. Remember, midpoint, midpoint, what do? Add them together and divide by 2. Remember that it's a point, that the x's have to get averaged first, and the y's have to get averaged second, so that the x-coordinate comes out first and the y-coordinate comes out second. So in our first one, we're going to take A and C. The x's are 3 and 7, and the y's are 5 and 8. And for B and D, the x's are 6 and 4. And the y's are 4 and 12. And because we're proving that this does not bisect, these should not come out to be the same. Okay, so in this first one here, 3 plus 7 is 10. 10 divided by 2 is 5. 5 plus 8 is 13. 13 divided by 2 is 6.5. Okay. In the second one, 6 plus 4 is 10. Divided by 2 is 5. And in the second one, 4 plus 12 is 16, and 16 divided by 2 is 8. And so you guys can see that the midpoints, they're pretty close, okay? 5.65, 1, 2, 3, 4, 5, 6.5 is right here, okay? And 5.8, okay, would be up a little bit higher. And so you guys can see that they are not having the same midpoint. So we're going to go ahead and say that AC and BD do not bisect each other. Okay, because midpoints are not the same. Okay, so if they did ask us for them to or prove or show that they bisect each other, we would have to show that the midpoints do come out to the same, and then they would. Okay. All right, guys, number 4. In the graph to the right, triangle ABC has coordinates of A, B, and C, and triangle RST has coordinates of R, S, and T. And they want to show, is triangle ABC congruent to triangle RST? When triangles are congruent, all of their sides and all of their angles match the same measurements as the other triangle. We have to use our properties of rigid motions to explain our reasoning. Okay. And so looking at our triangles here, does not look like they're the same, but our problem is that we have to prove it. And looking at what sides maybe don't match, I'm going to go with, right off the bat, those look like different lengths to me. So I'm wondering if I can prove that they're not the same length, and therefore the triangles will not be identical twins or congruent to each other. And we can also talk about rigid motions. All right, so let's go ahead and do the distance of BC and we'll do the distance of ST. If they do come out to be the same, we got to do a little bit more work, okay, and see if all the sides are the same. But if we can prove just one pair of sides is not the same length, then we should have it. Okay. So we'll go ahead and in BC, x is first. And so that would be a -6 and a -3. Y second, so -6 and -2. And in ST, we should have x is first, which is 5 and 2, and then y second, which is 6 and 3. Okay. All right, so let's go ahead and see what we get. This is really -6 plus 3. -6 plus 3 is -3, and -3 squared is +9. Remember, when you square numbers, they always should come out positive. And -6 plus 2 is -4, and -4 squared is 16. When we add them together, we get the square root of 25, which is really equal to 5. Okay. In this one, we have 5 minus 2, which is 3, and 3 squared is 9. And in the second one, 6 minus 3 is 3, and 3 squared is also 9. And this comes out to be the square root of 18. Okay, so one of our sides has a length of 5, and our other side has a length of square root of 18, which is not equal to 5. And remember, when they state the triangle's names, for instance, triangle ABC, BC is the last two letters. Triangle ST, ST is the last two letters. And if these triangles were congruent, BC should equal ST, and it doesn't. 5 does not equal square root of 18. So we're going to go ahead and say that BC is not congruent to ST because distances are not the same. Okay? And so now we can say that triangle ABC is not congruent to triangle RST. Okay? They also want us to use our properties of rigid motions. And so we're going to go ahead and say that rigid motions preserve distance between points. Okay? And the distance here is not preserved. So we can also say that they preserve angle measure too. So we'll say rigid motions preserve distance between points and angle measure. But distance was not preserved. Okay, we'll leave it like that. All right, guys, number 5. Okay. So triangle ABC has vertices with A, who's at x3, and B is at -3, -1, and C is at -1, -4. And we have to determine and state a value of x that would make triangle ABC a right triangle. And then we have to justify why triangle ABC is a right triangle. Okay. And so we can't graph A because we don't know exactly where x3 is. Okay. But we can graph B, which is at -3, -1. C is at -1, -4. And A is somewhere around some sort of x coordinate and then up 3. So A has to be somewhere along that dashed line. Okay. And they want us to come up with its coordinates to make this a right triangle. So let's go ahead and do this. We know that right triangles have to have right angles in them. Oops, R-A-G-H-T, right angles, which are formed by perpendicular lines. And we know perpendicular lines have negative reciprocal slopes. So if we know the slope of the one, we should know the slope of the other then. Okay, so let's go ahead and do the slope of BC. Remember, y is to the sky. And looking at B and C's coordinates, that would be a -4 minus a -1. Keeping the same order, a -1 would have to go first, minus a -3. On the top there, -4 plus 1 is -3. And on the bottom, -1 plus 3 is 2. And so now that we know that that's the slope of BC, we kind of know the slope of AB or AC, one or the other. All right. So we can now say that our perpendicular slope would have to be positive 2/3. So slope, remember, is rise over run. And so rising 2, running 3. So if I start at B and I rise 2 and I run 3, I end up there. But notice I didn't reach the line yet. So I'm going to rise 2 more and run 3 more. And now I believe I have found A's coordinates so that if I connect A, B, and C, this ends up being a right angle because AB would have the slope of 2/3 and BC would have a slope of -3/2, and those are negative reciprocals, which makes perpendicular lines, which makes right angles, which makes right triangles. And so now I can tell you that A's coordinates are +3, +3, which means that the x value that they didn't tell me before is 3. And that's one of the things that we had to figure out. Determine and state a value of x that would make triangle ABC a right angle. And now we're going to write a little bit of a justification why that is a right angle. So we're going to go ahead and say that AB is perpendicular to BC because slopes are negative reciprocals. We can then say that angle B is a right angle. And therefore we can say triangle ABC is a right triangle. Okay. All right. Hopefully that helps. And I'll see you guys on the next day of notes, which is Unit 11.